MCQ with one or more than one correct answer. Mass M is uniformly distributed over the rod of length capital L. The linear mass density of rod is lambda. Then, if alpha is equal to beta, then Iy is equal to 0, where Iy is the gravitational field in y direction. Ix is 2g lambda by r if the length of the rod is infinite. Gravitational potential is not defined at P if the length of the rod is infinite. If alpha is equal to beta, then Ix is 0, Iy is 0. So we need to calculate two things here. One is the gravitational field, another is the gravitational potential at point P. So how to calculate in gravitational field? We know the formula for gravitational field. So what is the formula for gravitational field? If this is the rod, lambda, this is alpha, beta, and this point P we want to calculate field, then you remember along I-axis G lambda by R. In the theory we defined it. Sin alpha plus sin beta. This is the standard formula. Similarly, Iy along y-axis G lambda by R cos alpha minus cos. Now what you have to do? Take alpha is equal to beta. What do you get here? Ix is equal to, substitute alpha is equal to beta. Sin alpha plus sin beta. 2 times. 2g lambda by r into sin of alpha. Here is substitute alpha is equal to beta. This will cancel. So what you get? Iy will be equal to 0. So directly from the figure we are getting choice alpha is equal to beta, Iy is 0. This is correct option. Alpha is equal to Ix 0, Iy 0. Wrong option. 2g lambda by r into sin alpha. B option is also wrong. So left over is A option is correct. Let us check the gravitational potential. To get gravitational potential, what is the relation between gravitational field intensity and gravitational potential? I is equal to minus dV by dr. So dV will be equal to I dr. Let us substitute it. From V to 0 dV is equal to integration from r to infinity 2g lambda by r into dr. So what we get it from here? 0 minus v 2g lambda log of to the base e infinity minus log to the base e into r. So v will be equal to 2g lambda log to the base e r minus log to the base e infinity, because minus sign is there outside. V is equal to 2g lambda ln or log e to the base r by infinity. Log of to the base e r by infinity is undefined. So choice C is correct. So option A is correct, B is wrong option, C option correct option, because gravitational potential is not defined at P if the rod is infinite, and D option is wrong option. So answer will be equal to A and C.